My glasses on.
Perfect. Okay. So let me go ahead and build a scenario. Let me get my handy dandy tools. There we go. Okay. So Wayne, the goal, right?
Yes.
You know, within networking, everything in networking has a client-server relationship. Okay. So you're gonna have a PC reaching out to another PC or server, in a sense, to go ahead and obtain a resource. Okay. And that's mostly what's happening within networking at the base level, right? And from a 3,000-foot view. Okay. There's specific things that's happening, but we ain't gonna get too deep at the moment. Okay. So in this exercise, we're gonna go ahead and, like Brian told you, we're gonna follow the path of the packet. And again, this is just a benchmark to see where you're at, where your knowledge is at, so that whenever we move forward with the CCNA studies and CCNP studies for network fundamentals, we can go ahead and help bridge some gaps for you, and so you can go ahead and be a successful engineer. Okay?
Sounds good.
So this PC, named after Donatello the Ninja Turtle, is attempting to get a IP address from the HTTP server. Okay? All right. So of course you see he has to take multiple paths to get there. Now what path he takes, totally up to, you know, how it's configured, some elections, spanning tree, routing options, et cetera, et cetera. And I'm just saying all these things to confuse you. So with that being said, we're gonna go ahead and take a look at the packet. I'm gonna ask you what the MAC address and the IP address looks like, source and destination for both values at each hop, okay? Each hop being each next device, okay?
Yes.
You can reach out, you can go ahead and reach out to fellow members in the Zoom, Mike, Claude, Brian, Max, you know, mostly everybody I've seen and witnessed, they can go ahead and walk a packet from its source all the way to its destination. Okay?
Okay.
So let me go ahead. And again, it doesn't have to be perfect. You don't have to be an expert, please. So you make a mistake, perfectly fine. This. Okay. So again, the network application protocol we're going to use is DHCP to go ahead and follow the path of the packet. Okay. So we're going to start off at the source being Donatello's PC. So this PC right here. Okay. Donatello first, we're going to go ahead and plug into the network and request to see, you know, hey, I need an IP address. You know, can anybody give me an IP address? Okay. From Donatello's PC, what is the source MAC address, destination MAC address, source IP, and destination IP? And I believe I left out the MAC address for Donatello's PC. Let me go ahead and fix that for you. There you go. Okay, so I just helped you out. There you go.
Why, thanks. Okay.
So what's that source MAC address?
The source MAC address is BBB.
Okay, and the destination?
Let's go to the first. Can you move the text tool off of the switch?
Sure. Yep, gotcha.
Would it be the destination be NNN? Because it's broadcasting. Wow. It's broadcasting out, and it's saying, "Hey, does anyone know what a DHCP server is?" And it's calling out. So it's I'm wondering because it's the closest to it, has to go through that node to go to its next point. So it's between
All right.
between.
No, you're doing good. You're doing good. So let's think about this, okay? Me and you being engineers, correct?
Yes.
So you said a key word. You said broadcast, right? So if we're broadcasting, what's that MAC address and the IP address for a broadcast message? Would it be that next hop, or is it, or within networking, is there a specific MAC address and IP address for broadcast messages?
I don't know the answer.
Okay, Brian.
What's up?
What is the MAC address for broadcast messages?
Say that for me one more time.
What is the MAC address for broadcast messages within a layer 2 topology?
Hold on, hold on. Let me close my door because I got background noise and I'm trying to listen at the same time.
No, go ahead.
You said, so say that one more time.
Sure. What is the MAC address for a broadcast message within a layer 2 topology? So basically, what's the MAC address for a broadcast message?
MAC address, is it the let me see. For broadcast.
It's all good. Mike?
All Fs.
There we go.
Bro.
Oh, Fs.
And I was scared to say it too.
It's all good.
Yeah.
It's all good. It's all good. So of course, Wayne, go ahead and take note. So remember, within layer 2, okay, MAC address, whenever you're trying to send out a broadcast message, that MAC address is always going to be all F, okay?
Okay, all Fs, write it down.
Yeah. All right, so, just like you were saying, right, the PC is trying to, get an IP address dynamically, possibly from a DHCP server. So with it sending out that, packet, what's the source IP of that PC?
I'm gonna go with 10.10.10.0.
Really? So it has the IP address of a subnet?
I mentioned that because it's going to the router, and I don't know exactly.
It's okay. It's all right. So let's walk through this again, okay? Me and you being engineers, okay? So your theory is correct, right? It's trying to get an IP address, okay? So the source wouldn't be a subnet, right? It wouldn't be that network address of .0, okay?
Okay.
So if it doesn't have an IP address within each decimal, right? Wouldn't the values be 0.0.0.0 if the value doesn't exist?
Wow. Okay.
Does that make sense?
Yeah, it does make sense. I've seen that, but I never realized what was happening.
It's all good. It's all good. It's all good. Right. But and let me just clear something up. Within Microsoft Windows, right? Their platform, they're going to have a way to where you'll get an IP address assigned if there isn't anything dynamically assigned or manually assigned. It's called an epistler address. So you can at least communicate with other PCs within a LAN that has the same IP address. But again, typically, right? Typically, that's what happens. But again, real world scenario, without a PIPA, let's say a PIPA didn't exist, doesn't have an IP address, logically, it's gonna have this IP address of 0.0.0.0 because it doesn't have any values for its IP address. Keeping it simple. Okay.
Can I ask a question?
Yes.
So where does IP helper fall in this scenario?
Layer 3 before layer 2. I love it. We'll get there. We will get there. Okay, and I'm gonna let you figure it out because you're the engineer on this call. Okay.
Okay.
So again, we're still at the first. We're still trying to analyze where the packet looks like in the beginning. Okay. So
Okay.
last but not least, what's that destination IP address of this packet that's leaving Donatello's PC and trying to get an IP address? What's the destination IP?
Would it be that of the part of the router that's facing Donatello's PC?
Why?
Because if when it gets to the DHCP server, it has to know how to get back. So it's going to put. I'm figuring that somewhere along the line it has to be, for lack of a better word, a header or tagged with some information to let us know this is the place that this knows where it's the place where it has to stop at. At least the last place that it came from. So it have to do something around that router level. It could possibly be the switch, but I'm not sure.
You're on the right path. So I'm not going to let you discredit yourself. You're doing excellent. Let's take a step back, okay?
Okay.
So remember, we haven't communicated or received anything back from any devices. Where all I asked you, right, is what's the packet look like once it leaves Donatello's PC? Not if anybody responds. Okay.
Okay.
So remember, Mike helped you stated, right? And you were correct. It's a broadcast message. So if at layer 2 it's all F's, what is it at layer 3?
So it's network layer. It's going to be where some kind of TCP/IP. So,
And brother, you got help. It's okay. It's okay. Max, what's up, Max? Still there? Max is probably still muted. Claude, so what would that IP address be for a broadcast message? Claude, you there?
Hold on a second, let me get my headphones on.
Can you?
Oh, Max, you there?
Yeah, I thought you couldn't hear me.
Can you hear me?
Oh, perfect. Claude, I got Max.
Okay.
So I'm gonna let Max answer. So Max, what is the IP address for a broadcast message?
Actually, after it. Okay, so that would be the 255.255.255.255. That's all of it.
Perfect.
okay.
Perfect.
255.255.255.
Make sense?
Yeah. Yes, it's making sense.
Perfect. So again, this is how it looks if the packet is leaving Donatello's PC, right, and trying to get onto the wire. Okay. Now, it's left, it's onto the wire, right? And the only other host that's on this network is the router, right? It's gateway. Okay. Now, that same packet is received by RA, okay? And of course, is there something that can be configured to go ahead and respond to this broadcast message for DHCP? Because if we take a look at this, right? Let's take a step back. The DHCP server is over here.
All right, Wayne, that's your time right there to jump in with what you was thinking about.
So DHC server is 172.16.1.0. However,
I'm glad you caught that. Let me fix that IP address. Sorry about that. There you go.
Okay. So the router is being configured. It's being configured to pass on the information Is that correct? So that it makes it to the next point, which then makes it on to
But what did
whatever.
what did you call it earlier? What did you call it earlier? You remember?
I said
You said it.
node.
You said it earlier, and you got Dave excited.
Oh, the IP helper.
There we go. Exactly. There we go. There we go. Okay. Right.
Okay.
So
Okay.
the DHCP relay agent is configured on R8. Okay.
All
So
right.
what's happening, right? So we're going to keep it simple. What's happening is just like a relay race. We know, and Brian remembers from our last session, we know that layer 2 broadcast messages are not forwarded on a layer 3 boundary, meaning that router isn't forwarding any broadcast messages at layer 2. So we need a way to where this DHCP discover message that's saying, hey, who's a DHCP server, it's going to go ahead and do a packet rewrite of that broadcast message and say, hey, the DHCP server lives on another subnet. I'm going to go ahead and broadcast what the DHCP server address is and respond to that DHCP discover message and take that packet from Donatello's PC and pass it on past the layer 3 boundary. I'm going to relay that to another network.
Okay.
Using my interface, my inside interface has a source IP address because Wayne, let's think about it. Me and you being engineers, right?
Yes.
Let's say, right, Donatello's PC sends this DHCP request, right? And let's say routers did, forward broadcast messages past the layer 3 boundary. It sends this 0.0.0.0 to, go ahead and clean this. Hold on. I can help it make sense. Hold on. Okay, so it's sending it, right? Let's say it does send it to the DHCP server, and the DHCP server does get it, and it allows it. And how does the DHCP server know where to send it back to? Can I send it back to an unknown IP address?
No, it has to know. It has to be something that's tagged inside the packet or the frame, so that it knows where to go back to. It has to be there.
Exactly. Because if I send a packet, right, with a destination address of 0.0.0.0, it doesn't exist.
Exactly.
Okay. So, excellent job. So now that Donatello's PC knows about the DHCP server from the IP helper address on that relay agent, now we can go ahead and manipulate our packet. Okay, so I'll give you a hint and I'll leave your destination IP right there. But now from R8 going to R9, what does the packet look like now? That source MAC address.
Well, I'm looking at either, so from R8, it's got to be tagged to that. So the destination MAC address.
Nope, we're on source still. The source MAC address.
Oh, the source. Sorry.
Of the packet. Yep, it's all good. So it's leaving R8 and going towards R9.
So we have RRR, that's on the MAC address. So we got NNN coming out, it's going towards RRR. Destination MAC address. It has to be the router. I'm going to say RRR.
Why?
The router is configured to IP helper. It's configured to check and see, or more or less pass things on to its next destination or stop it. So I'm thinking it has to be something in that router that is tagged to the destination. It's got to be part of the destination because it's coming out. I mean, I see it going to the
You're right.
switch.
No, you're right. You're absolutely correct. Okay. But here's the thing I'm going to point out to you. One of the traits of future engineers and system admins, okay, is understanding the scope of a question or understanding the scope of an issue. Okay.
Okay.
My question to you was, and I already helped you out a little bit. We already rewrote the packet and said, hey, R8 is going to send it out towards the DHCP server. My question was, what is the packet going to look like leaving R8 and going towards R9? But hold on. You did answer the part to where after Donatello's PC discovers and learns about the DHCP server from the IT helper responding to it, how the packet's going to look then. So great job there. Okay, but I was actually asking how the packet's going to look leaving R8 and going towards R9. With that source map, destination map. Okay.
Okay, so we needed to, the next point is the next router over, that will be YYY. So destination would be YYY.
Okay. And what's my source?
The source would be LLL.
Why?
That's the last point that it reached, the packet reached. So it's now saying, okay, next router up, I got this coming your way. And here's my source, here's my information that you need, here's the packet for it. And
Perfect. Okay, so what about the source IP address?
so it'll be an IP address, would be whatever the IP address is. Because right now we had it at 0.0.0, it still hasn't been configured yet. I'm not quite sure how it changes over. Right now, it's because we're still in a part where we're discovering, right? We haven't really made a full request back, as far as I know. So I don't know.
It's okay. It's okay. It's okay. You're on the right path. So we're gonna again, because you're the main engineer on this journey. Okay. So we're gonna pull another engineer to help you. You're saying the right things as far as using a DHCP relay agent or what have you. We're just gonna pull in a little bit more help. So I'm gonna bring in the engineer Claude to help you define what that source IP is gonna look like and why. Claude, you got a second?
Yeah, we're here. Can you hear me?
Yes.
Okay, so where we at? We between 8 and 9? Where we at?
Yes. 8 and 9.
Okay. So we still talking about that packet, right?
Still talking about the packet, and he defined what the source and destination MAC is going to be, but I'm asking him what the source IP is going to be, and he has a standstill because again, Donatello's PC doesn't have an IP address. Okay. But he does understand that we did use a IP helper on the inside interface for the 10.10.10.0 subnet to respond to that DHCP discover map. So if you can help him out a little bit, what that source IP is going to be and why.
All right. So check this out, Wayne. Check this out. Let's say I'm living in Florida. All right.
Okay.
That's where PC Donatello is. Okay. And you are living in Massachusetts. That's where DHCP server is.
All right.
Okay. Now I'm going to address this letter to you, just like how I learned in the second grade. You know, I'm writing down there your name, your address, your zip code, all that good stuff on the letter. Okay. And I'm gonna drop that in the mailbox. Now, let me ask you this. That letter is going to get picked up by some mailman or some mail lady. You agree?
Agreed.
Is it going to get taken to Massachusetts when he picks it up that same day?
No, there'll be some kind of stop-off points.
Okay. So it's going to get dropped off at some processing center or some other mail sorting facility, right?
Right.
What's the address on that letter still?
The address, the letter hasn't changed. It's still going to be the destination and the source.
Okay. All right. So that letter stops off in, let me see, we in Florida. It stops off in Pennsylvania. And it gets sorted and handled somewhere, and somebody else puts it on another truck. Okay.
Mhm.
When it's in Pennsylvania, is this next stop in Massachusetts where you are?
Not probable.
Okay. Okay. But what does the address on the letter still say?
It still says the same address.
Okay. So now that puppy's done stopped off in let's say it done stopped off in Delaware somewhere, and then went to Delaware. Okay.
Uh-huh.
And it's being sorted, and it's going to another truck. And now that piece of mail is loaded out, going to your address in Massachusetts. Now, it's been stopped off at what, 4 different postal facilities?
Yes, it has.
Okay, but what never changed?
The destination IP address never changed.
So do you got the idea what Dave was looking for?
He's looking for it to stay the same. All right, so the source IP remains the same. The destination IP is 172.16.1.25. The source IP, Dave and Claude, my question is because we never identified the source IP yet, except for the 0.0.0.0. Does that stay the same?
Okay, so good question. It does not. Okay, so let me let you know how DHCP relay works. Okay, so what it's going to do, it's going to see that it has a host that doesn't have an IP address. Within the technology, right? It's going to say, okay, perfect. So I know that if I set this as my source and I send it out, it's not going to have a way back. So I'm going to set the source IP for this packet that I'm rewriting for Donatello's PC to my inside interface, 10.10.10.254, which is Donatello's default gateway, which is the inside interface of router 8. Okay. Within again that DHCP part of the packet, right? Layer 7. If we take a look at that, and we're going to take a look at that once we do some packet captures with Wireshark. We're going to take a look at it so I can show you. It's going to have the IP address that 0.0.0.0 of Donatello's PC, but more specifically, it's going to have the MAC address of Donatello's PC, so that when it comes back from the DHCP server to offer a potential IP address, R8, being the relay agent, knows, just like a relay race, who to give it back to once it goes around.
Makes sense.
That makes sense?
Yes.
Okay, perfect. So that IP address, the source IP is going to be 254, okay?
254.
10.10.10.254. So this inside interface, okay? All right, perfect. So now that we properly know how this packet looks, leaving R8 going to R9. So R9 now has that packet. Okay. How does that packet look leaving R9 and getting towards the DHCP server? What's the source and destination MAC, and what's the source IP address and the destination IP address?
Well, the destination IP will stay the same. It's going to be the DHCP servers.
Why is it going to stay the same?
Because that's what it's calling out. The router knows that there is a DHCP server, and it's calling out to it. It knows what it is, so it's going to stay that DHCP server's address is not going to change. It knows where it's going.
Okay. Okay. And what's that source IP address?
Source IP address was 10.10.10, but since we're on the second part going from R8 to R9, we have a 4.3.2.0, a 4.3.2.0, subnet of 30.
So it's going to be 4.3.2.1.
I'm not sure, Dave.
Hey, it's all good. It's all good. Hey, again, and there's perfectly fine. This is the sandbox. So mess up here, perfectly fine.
Okay.
You don't have to have it all right. Okay.
So I know you're choosing 1 because of it, subnetting. So because you got 4.3.2.1, what else could it be, or does it automatic default to 1?
We'll come back to that. We'll come back to that. But I just want to go with what your choices are right now and why. Okay.
Okay.
So and let me move this down a little bit. We still have to define the source MAC address and the destination MAC address, leaving R9 and getting towards the DHCP server.
Okay.
So what's that look like?
We have a source MAC address of LLL or LLLL, and a destination MAC address of YYYY.
Okay. All right. Okay. So let's talk about this. Okay.
Okay.
So I want you to remember this rule of thumb. Okay.
Listening.
Within any type of, delivering packets, at a layer 3 level, right? As far as source IP to destination IP, that value will never change. Of course, DHCP is a unique situation, of course, because it's doing packet rewrites, right, for the DHCP relay. But typically, let's say Donatello's PC had an IP address and is trying to reach the server. No matter how many subnets it goes through, the source IP address and the destination IP address will never change. Going back to Claude's example, if you were sending him a letter, right?
Right.
It's gonna have your address, right, which is your IP address. It's gonna have Claude's IP address.
So that makes sense.
Wouldn't it be wrong? Wouldn't it be wrong if the USPS changed your letter to be there?
Yeah, it doesn't make sense.
Mailing address.
Yeah, that wouldn't make sense.
Does it?
No. So the source IP address, which stays either the 10.10.10.254.
Exactly. Okay, and that's part of the DHCP technology, right? It's putting that IP address there, so the packet has a way to come back from that DHCP server, whoever is providing that resource to that client. Okay. Right. But again, typically regular packet delivery from a source to destination, bro, the source and the destination IP address is never changing.
Got it. Make a note.
Make sense?
Yes. Claude broke it down. He said it. He made it. I said it wouldn't change, but yes, it makes sense. Where I went wrong, I got it.
Okay. Now let's go to layer 2 again. We haven't went higher on the OSI model. We're still staying in the network engineering section of the OSI model. Okay. So we're not going past layer 3. We're now we took care of layer 3, right? Let's go to layer 2. Here's a rule of thumb. What will change is the source and destination MAC address every time that packet travels from device to device.
Okay.
Okay? Because again, in the OSI model, layer 2 is the data link layer.
Right.
The data link layer, okay? It needs to know how to send that data per a link. We're gonna keep it simple. It needs to know how to send data per a link. That link is connected to an interface. That interface has a MAC address. It can only communicate on a link using a MAC address. Every link is going to change. It's going to have a different MAC address for each link. That's why it's called the data link layer. And it uses MAC addresses. Does that make sense?
Yes, it does.
Okay. So
it makes sense. It makes sense now that you're saying it this way, because you know, how I learned MAC address. How I learned MAC address, I thought it was something that was, unless you spoofed it, it's something that is within a device, is a ID within a particular device. But when we're talking about data link layer and we're communicating from one point to another, that's where I was having.
And we're gonna keep it. And we're going to keep it simple. We're not going to throw in big words that, you know, that's pointless. We're trying to learn. We're trying to learn it, right? We're going to keep it simple. I personally love Saturday morning cartoons, so I'm going to mostly keep everything simple. Okay. So that's how I understood it. That's how I understood it. Okay, and it works for me throughout the years. So remember, rule of thumb: layer 3 will never change. Layer 2 will always change per device, or the technical term is per hop, meaning per device, okay?
Layer 2 will change per hop.
Okay?
Got it.
With that being said, remember my original question to you. How is the packet going to look leaving R9 and getting towards the DHCP server? That being said, what is the source MAC address and what's the destination MAC address?
So the source will be VVVV.
Okay.
And destination will be CCC.
Perfect. Perfect. Okay. Now, you did excellent, because we're going to assume that R9 doesn't have in its memory or its MAC address table, or I'm sorry, in its ARP table, any information about the DHCP server just yet. Okay. So it's going to send it to that next hop. Okay. So you did excellent. Exactly the rule that I told you, you're following that. So we're not going to get into spanning tree. That's going to be, we'll have another packet section talking about spanning tree. But let's just say switch 3 has it now, and it needs to send it towards the DHCP server. Okay, what's going to be that source MAC and the source destination?
If we got a straight hop, like you said, we're not talking about the spanning tree, and there's no block port. Then it's going to be source MAC is CCC, and the destination MAC will be GGG.
Perfect. Perfect. Okay. So now switch 6 has it, and it needs to send it down to the DHCP server. What's the source MAC address, and what's the destination MAC address?
So switch has it. So we're gonna source is GGG, and the destination MAC is ZZZZ.
Okay. Is that your final answer?
Final answer, Bob.
Okay. All right. So we're going to test your theory. We're going to test your theory. Okay. Great job following this packet from the source all the way to the destination. Okay. Just want to give you a bravo. So great job. So we're going to test our theory. Okay.
Okay.
So what we're going to do is a little tool to where we can, you know, see. Oh, let me go ahead and take that out. Hold on. Very sad. There we go. It's a tool to where we can see the packets traversing each link, okay, within a network, okay? It's called Wireshark. I'm not sure if you ever heard of it before.
Okay? I've heard of it. I've used it, but I broke it down like this. I'm glad that this is happening.
Oh, it's all good. It's all good. And basically what Wireshark is letting me do and how I configure it, of course, in the real world, we would configure it, what have you. Basically, it's mirroring all traffic that's traversing throughout each link and show me how it looks from a packet level all the way from layer 1 all the way to layer 7. Okay. Okay. So what I'm going to do, I'm going to initiate Donatello's PC to attempt to get an IP address from the DHCP server. Okay. We're going to take a look at how that packet looks. All right. Okay, Dave. Let's go. So first, let's check our PC, see if it has an IP address. So it doesn't. So remember what I told you. If it doesn't have an IP address, what's the IP address is going to be assigned? Or 0.0.0.0 with a /0 subnet, correct?
Yes.
Perfect. Okay. So, of course, the MAC address doesn't match up, but that's not important right now. Those changes per device. So, I'm going to go ahead and request an IP address. Cool. Well, Wayne, with your help, I was able to get an IP address. Great job, engineer. So
Thank you.
let's take a look at how that looks in the wire. Okay. Stop this. Stop that. Stop that. Okay. So first capture. Okay. This is on switch 2. And leaving this interface going towards R8, okay?
Okay.
You get a 0/0 going towards R8. Let's search for our protocol. Okay? Just like we spoke about, okay? Just like Mike told you, that broadcast message, and you were correct. It's going to be all F at layer 2. Okay? And just like Max told you, it's going to be 255.255.255.255 has the destination at layer 3. Okay?
Okay.
All right. And so that's the first part. It's going to be in there. Okay? And I want you to remember this. Within that, because again, DHCP, it's a layer 7, right? It's an application protocol, network application protocol, okay? And so within that application protocol, it has a mechanism to where it's going to have different fields. And within this field, right, you're going to see within a DHCP discover message, it's going to say who is that client or that PC, the Donatello's PC who's requesting this information. Here it is. Here's his MAC address. Here's how we can identify this specific PC that's requesting it, okay?
Okay.
So, with that being said, now let's go to R8, okay? We're gonna go to R8, Wireshark capture, and take a look at this interface, okay? Something changed. Just like we spoke about as far as the DHCP relay agent, we needed an IP address assigned to the packet before it crossed that layer 3 boundary, okay?
Right.
So now you see the packet has an IP address.
Of 10.10.10.254.
Right? But how do we know that now that we changed the IP address, how that packet's going to come back just to Donatello's PC? Because there's a whole bunch of other Ninja Turtles, including Master Splinter, and they all got PCs. So how does that router know to send it back to individual Ninja Turtles or PCs or Master Splinter? You know what I'm saying? Within the DHCP discover, right? We just like I just stated, it's going to have nested that MAC address for that specific PC. That makes sense?
Yes, it does.
So you don't have to worry about. Go ahead.
So once it gets to that particular router, and it knows what to do because it keeps a register of the MAC address. So it knows exactly what Donatello's MAC address is, and it'll send it to it. All you got to do is get it to that point, and it takes over from there.
Exactly. It's just like a relay race. It's going to hand it off. Okay. So once Donatello gets there, right, he's going to go ahead and hand it off, and R8's going to handle the rest. It's going to handle the rest. Okay. Then it's going to go just like you stated. It's going to go all the way there. Okay. So,
David, thank you. You made this very easy to understand. And even though I might have heard it 100 times, this is a very easy way to teach it. Thank you, Claude and Mike.
I guess he do all
it's
right.
all good. It's all good. It's all good. You know, I can't take all the thanks. It's everybody, you know, Matt.
I mean, I don't know why they explain it to us this way before.
Well, job security is a thing. So they can,
Jeez.
if
I
they
could teach
can
this tomorrow.
throw some of
I can remember this and teach this probably tomorrow, and I couldn't do it until
exactly.
today.
They're gonna throw a whole bunch of big words to confuse people, right? But once you read beyond those big words, and Claude, he doesn't like big words neither. So, once you make it simple, then you can go ahead and say, hey, calm down. You know how it works. We see it all day, every day.
Yeah.
We see public transportation, we see subways, we see buses. We see the DHCP process and packet process all day with human beings.
You just got to relate it. You just got to point the relation.
Good.
It's awesome.
Good. Hey man, any other questions?
I know we talked about doing it later, but since it's here now, I was reading about it. Can we talk a little bit about the spending tree?
Holy.
Hey, that's what. hey.
Do you want to counsel with your advisory board?
Hey, look,
Brian and Claude, what have
Wayne,
you, before asking?
I just want to know one question. How does the technology work within the switch that it knows how to block a specific port so that we don't have the looping? I'm like, how is that working? I don't know. My head's not wrapped around it.
Hey, Dave, quick question.
Because I'm old school. Like when I started doing this stuff, how to switch, it wasn't a smart switch. It was.
Here you go, Wayne.
It wasn't. Yeah.
In simplistic terms, the switches talk to each other across the wires, across the multiple links that they may have, with something known as BPDUs. That's how they figure out how to forward, who's going to be blocking, who's even going to be the big dog of the tree. So we'll just keep it at that point right there.
Okay.
But just remember, these switches, I know you said you probably talked to some you were using dumb switches in the past.
Yes.
Or they might have been referred to as hubs back then. I don't know.
Yeah, they were. Yeah,
okay.
They were.
Okay. Switches today, they talk to each other. So let's just we'll just leave it at that. And that can be a whole nother yeah. I'm sure Brian will fill you in. But
hey, look, I got you. I got a topology to show you, my man.
and Brian, you better tell them the right thing because Wayne, next Thursday I will create a layer 2 topology, and you will have to converge it.
Okay.
Using spanning tree. We're not talking about CLI. I'm talking about just like how we did. No CLI.
By hand.
Just words.
Yeah.
Okay.
By hand.
Hey, look,
okay.
it's no access to no you can't access no switches. You can't touch nothing. The only thing you got is a pencil, a piece of paper,
and an understanding.
Understanding, your knowledge. Like, look, everything that you got. At first, I didn't understand none of it, but I got that. Look, I had to get a deeper understanding of it because you got to be careful with what words you say too. So
let's give me a couple more weeks then. I don't want to do it next week. Give me a couple weeks. A couple weeks at least.
Don't be nervous. You got it next week. You'll have support. You'll have support next week.
Yeah.
Wayne, we're gonna do it next week. Okay.
Okay.
No. Hear me out. Right. It's not because we want to scare you when we want to do this, that, and the third. Right. One of the key things in our group is that we want to prepare people for things they're not going to be prepared for, right?
Okay.
Because in an actual environment, has an engineer, has a system admin, has a CISSP, cybersecurity, CISO, whatever. There's going to be things that happen that you just can't be ready for. You can't fully be ready for.
Makes sense.
Right? But as long as you know the why and how to find your way to the answer, I guarantee you everything's going to work out. So next Thursday, we're going to do it. We're supposed to be doing Wireshark next week, but it's perfectly fine. We're going to go ahead and do that next week, next Thursday.
I think I heard Zamir in the background. There, you got support.
No,
You
I just
definitely
tell him
do.
you
Have
got
resources.
support. Like we'll get it. Like yeah, you got
Man, I
support.
appreciate y'all. I appreciate y'all.
Because
Hey,
I'm
and even if
We
you want to
have
jump on like a
resources.
call or something like that before time, like we can. We can go through the whole topology, explaining exactly how different things work before the actual time frame comes. So
Mhm.
we got you.
This is why I even though my specialty is something different, I just felt like, how can I go any further without understanding networking? I just can't. I just felt wrong. Like you have to go back and get this down. So I'm so glad that Brian introduced me to this group. I appreciate y'all. Really. Thank you.
It's
Oh,
all
no
good.
problem,
It's
man.
all
more
good.
than more than
It's
welcome.
all good. So yeah, like they said, they got resources. You can reach out to everybody in the group. You just can't reach out to me for this next session because the kid gloves come off.
All right.
Okay.
Appreciate it. Let's go.
So, all right, brother. All right, folks. Well, this is a great session. Thank you, everyone, and I will see you guys next week.
Okay,
All
All
right.
right.
See you next week. Thank you.
All right, y'all have a good one.
All right, folks.
all
You
right.
too.
Everybody have a nice one.
You
Good
too.
night.